So please have a warm welcome to Roberto!
Thank you. Hello. Well, let's give you some context. I was born as a developer. I used to be in the last 10 years, like 15 years. And 3 years ago, I started this journey around data, okay? And to give you some context, in the company where I work in this moment, we have a big team of analysts, of data analysts, and we need to provide them a lot of data. Okay, so with my amazing team, we tried as developers to switch to our mindset with a data-driven approach, and we started from scratch. We started from relational database, and now we are on the data and Delta Lake. So this session is about this transition, about this path that leads me to the point we are now, and since my developer bias is around the platform as a service, so we don't want to use VMs, we don't want to use infrastructure, I want to show how to do that with the minimum amount of infrastructure, so in a serverless way. So this was our journey. So we started from the relational database with tables, okay? So after a few months, probably, the solution didn't fit anymore because the data grew up, okay, a lot. And we tried to have some variations with JSON. So how many of you used JSON inside SQL database or SQL Server? Wow. Great. And so you probably know that's amazing because you just put your document, you don't deal with the schema, and that's all. With JSON value and open JSON, the rest is up to SQL. Okay. But it didn't fit anymore after a while. So we tried to go with the data lake, and we discovered a lot of things. We discovered the concept of landing, so just use the data lake as a file storage just to land batch of data, okay? And then we tried to structure it by ourselves, so by making a partition strategy by ourselves, so directly organizing the files into the data lake to then go and approach right now to a mixed model where we have some partitioned data lake part and some other Delta Lake that is managed by Spark, actually, okay? So this is some glossary for the session. So data movement is the process to move a large amount of data from A to B, and you can have some challenges during this movement. For instance, if you are lucky, you probably work in a append-only environment. So your movement is just a difference, just incremental slice of data that comes out day by day. Okay, but if you're not so lucky, you should probably deal with the concept of updates. So the upsert in SQL, but so you just can't append, but you just need to update the existing data, and if it's in the data lake, it's not so easy. What is the landing storage? In our data governance framework, the landing is the storage that we used in the nearest part of the source. So it's very connected to sourcing. Sourcing is the process to get data from outside, so from an API, from somewhere else, okay? And typically, that kind of data is put into the landing storage. So it's not trusted yet, okay? What I mean with trusted, I mean that we perform some check around the data to put in a vault, okay? And this vault can be the database itself, the data lake. We can do with Spark, that is an open source technology by Apache, and it's the underlying technology also of Databricks. And there's the technology that we can use in Synapse, that is the tool we are looking at today, for big data. I don't really have a definition for big data. It's data that's really big, but I have one for cloud. Okay, but we have so many definitions of cloud in those days. I really like the one of Magnus and Zachary, but definitely we have so many, but I really prefer the one by Mark, actually. Yeah. Well, let's go with the sourcing part, okay? In this scenario of today, we have three kind of small data set, okay? I don't even call dataset, they are just JSON documents, okay? That resembles the advertising world, so clicks, impressions, conversions, okay? And we want to put them into your data lake, data framework, data platform, okay? So data platform is the union of all this part of data management, movement, sourcing, and so on. So for this demo, we're starting from scratch, except the ingestion part. So I leave it on the GitHub, and that's essentially a C# application, okay, like this. So well, this is the entry point, and here I'm emulating the sourcing by generating some reports. Okay, so I generate some random reports that you can actually take from an API, okay? But for this demonstration, I generate them and I write on the relational database. Actually, it's commented because it's the more time-consuming part, but I prepared it. And I performed 4 different write strategy. The one is in the landing zone where the concept of batch resembles that you just take what is from the source and put in the fastest way into the storage. So no transformation, no logic, nothing at all. Okay, just put your data into something secure. That is your landing storage. And how I did that, just with the simple write to the blob storage with this pattern. Okay, so I'm organizing by myself the data lake. In this case, it's just a new document with a GID into this batch folder. Okay. The second strategy is with the partitioned data lake. So in this case, let's go into the details. I use another folder and I'm organizing the structure into types. So the actual report type, and then here I split them into year, month, and date to have a more organized structure inside the data lake. Why I did this in this form? Because this is the standard that can be read by Spark engines to push up these parts as parameters. Okay, so when you work in a data lake with this convention, okay, you are working by setting those segments as segment parameters. So you can reuse them to filter out your data, and it's very effective. After that, I also tried another strategy that can be very interesting when your data doesn't change. So if you are in append-only mode and you don't have a late arrival that updates your previous data, you can go with an append strategy that can be made with the API. Well, okay, hey, stop it right now. Okay, with this native API of the blobs, okay? We can say append block, and we can use just a single blob to append the data. Of course, this stays just for that kind of data that is text files, okay? CSV, JSON. So a JSON after JSON can be read as a JSON lines format, so JSON-L probably. CSV one after that is good, probably, but a Parquet file, one after that, is not really suitable. Even an XML is not really good, probably. So this very depends about your data format, okay? So in this case, since I'm appending, I'm not really partitioning for year, day, month, but I'm just pulling all together in a year JSON report, okay? And finally, I made the same thing of step 2, but with Parquet data format. How many of you knows Parquet? It's amazing. Okay, good. For the other ones, I would say that in this case, but through C#, I'm just changing the format. It's not really a good approach, just for the demonstration purposes. But just to be sure that you understand, Parquet is a columnar format to store your data. So when you have row store formats, you just have like 1, 2, 3 rows, and if you have a billion rows, and you want to make a sum of a specific columns, think about the logic under the hood that probably scan each row, take the column, and then put all together to get the sum. Okay, with a columnar store that in SQL Server can be the cluster, the index, the column store indexes. The concept is that you just change the underlying storage format to organize all the stuff into columns. And it's really, really impressive in terms of performance with an analytical workload, because if you want to perform a sum on an aggregate operation, you just read the column, the single column, and then you just can be faster. And in 99% of the column store formats with Parquet, SQL, even Power BI and Tableau have their own column store formats. There's also a great compression in place. So when a row store data set can be like 1 gigabyte, the column store version can be like 10 megabytes. Okay, so not really so huge, but real with about 20, 30 per of compression on average. Okay, good. So, well, I want to run this, and I want to, this is a prefix for my data lake, so everything would be pushed on this prefix. I go to Azure to take the connection string of the storage account. IC should stay for IglooConf. Okay, good. And I try to run this one in the background. So, finger crossed that is generating some reports. Let's wait a second line and we can go ahead. Well, internet, please. Okay, good. It's generating. Where is generating? So, let's go now to Synapse. Well, Synapse is one of my favorite tools in the last couple of years because it wraps up all the stuff about data. So it's not only a wrapper, actually. It gives you also some unique features like the serverless pool that we are just looking in a few seconds. Okay. For instance, let me investigate our storage account in the reports folder. Now, a folder that is called IC has been created right now. And we have those 3 versions. Okay, the batch one, of course, is a collection of documents like this, so you can have just a preview. Okay, each one is an array of events. Okay, and then we can have the partitioned, the append one. So I mean that with the append one, I'm just partitioning by year, so just one document for an entire year. It's not really a real-world scenario, but just to be sure that you understand. And we also have the partitioned one. The rest of the demonstration will be focused on this partitioned one because it's already structured, already organized, well organized. Okay, so in this case, we have for each month, for each day, JSON version and the Parquet version, and you can see the difference in size. Of course, this is not really meaningful because if you have you see the difference when the data is so huge, so you can see the compression in action. Good. What is the really nice point of Synapse is that feature that's called a serverless pool. Okay, so when you have Synapse, you have embedded sort of DB. Okay, this one. Okay, that is also seeable by SQL, by the Management Studio, because it's TDS compatible, so you can connect it by SQL Server Management Studio. And this is one. This is not really a database, okay? It's something virtual that acts as a bridge between the SQL world, so the TDS world, and the data lake. So it's a bridge. in my personal definition and opinion. What I mean that if I generate a query like this that I take out and I put here to be okay. Well, not really. Okay. I'm telling this bridge to open this parquet with this format, okay, auto-infer the column the types, and produce an output. So with this serverless pool, you just can connect to Synapse and get out the result in a SQL, in a tabular format, okay? But we can also do more, of course. This is partitioned, okay? So we can just say, hey, there's no a fixed year, month, or day, but we can have wildcards, and we can spend our wildcards, excuse me for the indenting, okay, spend those wildcards here with results.filepath1, that is the first segment. I don't know if why it's one based index, okay, but it's the first segment of the wildcard path, okay. And we can also reuse, like in a concat fashion, okay, well, 2 and 3, and we can have like a date, and we can also cast as date, and now it's slower because it's actually exploding the wildcards. So before that, it was just reading that parquet, that single parquet. Now it listed all the parquet inside the wildcards and read all the stuff and promote the wildcards into a parameter. And yes, can we reuse it in the query itself? That's be good, because if I can, if I put a where date is lower or greater than, the underlying engine will go just through the partition, just to the set that is of interest, okay, without scanning all the other millions of files that we have. So this is really a good value for your buck, since it's also very cheap, because it's the billing model, the pricing model is based on the actual data, the actual volume of data that you process. So if you process a huge amount of data, you pay more, but if you just use the bridge to read gigabytes of data, it's a fraction of $1, okay? And of course, we can use this approach also to read JSON. It's the same, and since the audience is already accustomed with the JSON format, I don't give too much details about the JSON value function that can be, of course, extract the values from your JSON documents. In this case, we can put a cross apply here to the OpenJSON to promote the array into single fields, and then we can take out some fields with the JSON value. And this is, of course, working inside our management studio, where we can create a view, for instance. So we can have a view, and you can even map in your application that view that seems to be a SQL view, but in reality is something that is hitting the data lake in real time, okay? So this is my, okay, well, it's continue generating, so we can stop it because we have some good data sets to start with. And this is the ingestion part and also the exploration part of our journey, okay? What we learn internally with this approach, that you can use the bridge, the serverless pool, to perform some sort of investigation inside data, and also to give those data to the outside users. One question may be, but is from the performance point of view, how is it effective? Okay, it's not really like a data warehouse. It's not really like a SQL engine, because under the hood there are files. Okay, so you can imagine like a pool of machines that pulls up those files fast, but not so fast as another context. So don't expect to connect directly or your business intelligence to this one. Probably it works in some scenarios, but it's not so so effective. Okay. So after that, we had the challenge to consolidate our data sets, okay? And we had some alternatives, okay? One is the data copy activity in Synapse. How many of you knows what I'm talking about? Now a few, okay? We have many. Now we are going to investigate all of them, but data flows is something related, stays on Synapse, but is also related to Spark pools. So think about these three as the most high level and the most low level way to aggregate our data. And actually with Spark and data flows, we can have more and more than aggregation, okay? And we'll see later. We talk about the Synapse serverless mode, and just as a reference, we have also a dedicated pool in Synapse. The dedicated pool is just a former data warehouse in Azure, so it's just a relational database optimized for analytic workloads. And now it's called Synapse dedicated pool. Okay, we don't use it in this demonstration. Now I'm start to consolidate our data sets, our reports. It's not a data set yet. That's here. So as you saw, we generated with the C# application those three reports, okay? Let's take the first, the clicks. We have just 1 year because of the timing, okay? In this 10 minutes, generate just 2 months of reports, okay? And we want to wrap all the stuff in a single file. Why? It's not really, in the real world, you don't want maybe to wrap all your stuff in a single file, but probably you want to aggregate by month, by day, by, I don't know, which is the aggregation that you want to perform, okay? But in this case, just to be simple, we are aggregating all the stuff of a single report type in a one file. To do this, we can use a pipeline. Actually, it's a very simple pipeline with a copy data action. And here, do you see? In the back seats? Yeah? Okay. And here we use a new data set, the DataLake Storage Gen 2, that is different from Gen 1 because it's the new one and the only one that has a future, okay, right now. And that's the same of blob storage. So if for the people who doesn't know the difference between DataLake Storage Gen 2 and the plain blob storage, is now it's just a matter of initial configuration. And the Gen 2 storage is actually the blob storage with a hierarchical namespace, so with folders, for instance, okay, and a protocol to go inside it without the necessity to use HTTP. That is the difference that made it really fast for Hadoop technologies. So let's read a parquet from this folder. I can feel also other parts, but it's buggy, the portal, so I need to wait just right now, and after that I can fill the other parts. Actually, what I want to do is to say, hey, take all the IC/partition/ type clicks, year, month, date, star.parquet into a single file. So here, to tell this story, I can see, IC, partitioned, yes, type clicks, okay, year, wildcard, month, wildcard, and day, wildcard. Dot parquet, let's preview the data. Okay, that's good. And since I promised you that if you organize the data set inside your data lake with that folder structure, with that segments, we can use those as a parameter. We can just say enable partition discovery, and this activity will push up the new columns over there with the inferred values from the URL. Okay. After that, okay, nice. Copy. I want to sync. Now, my concern is that I'm creating a new datasets for each part. In real world, you can just have one or two, and you can use parameters to reuse your connection, to use a dataset pointing to the same storage. But to be fast in this demonstration, I'm creating new stuff in each step. Okay, so I know that it's not optimal, but just to be fast. So this is another dataset that stays here. Few seconds more waiting. And now I want to tell this activity to put in a single file, merged from the several files it finds into IC/ aggregates, new folder. And here I can say type clicks.parquet. Oh, yeah, the casing. Okay. Good. Merge the files, and I can debug it. The debugger is my best friend in Synapse because it's really fast, and we can use it to test our activities. In this case, it takes really few seconds. I hope it's finishing. Okay. Amen. Yo. Please. Okay. Just a couple of hours and it's finished. Please. Usually it takes 10 seconds to perform a ticket like this. Okay, so let's see the preview. Okay, succeeded, good. It read about 33 files and it put into one single file. Even in this parquet to parquet aggregation, we see the savings because of the thing I told you before. Okay, so with 4 megabytes, we have a 33 parquet that was really compressed and compared to the JSONs. Okay, we can see the results here in the aggregates folder. Okay, but now we want to scale up we want to perform something more scalable in terms of reuse of the code. So we have 3 types. So I want to aggregate all the 3 types. If we have 100 types of report, I want to do the same aggregation, but without writing 100 pipelines. Okay, so I change my pipeline, telling this. With this specific activity, I can read, like listing the blob storage, okay? So I can say, hey, again, data source in Parquet, pointing to the storage with this file path. Give me some seconds more. The portal has some bugs. It's something that you can discover by yourself. So you need to make some little workarounds. And here I say, hey, go to the partitioned folder. Good. And as an action, try to list the child items. I just put the relation just to debug it. Okay, not because I want really execute the second part, but just because with this relation and the breakpoint, it just executes my first activity without executing the second. If I don't make that connection, it started in parallel. Okay, so let's see okay. Good. Let's see the result. Not yet. Okay, so it listed all the 3 types it found dynamically in that folder. So we can use a for each. Excuse me for the space, but I want to ensure that the resolution is okay. Huh? Okay, so for each, and here we can say for each get metadata child items. Okay, so take the output from the previous activity, go into the child items array, and for each one, perform the copy data. So let's cut it and paste here. But there's a problem that this copy data is strictly related to this type. Okay, so I want to push this is as a parameter, okay? So I can say concat of this stuff, but this comes out from the loop, okay? Well, and I can use this item dot name. Why dot name? Because I was fasting while working, but the structure was the child items, an array of the couple name type. So I need to say item dot name. The same stays for the sync, because in this data set I'm hard coding the name of the files, and this is slightly different because I can just say here to use the incoming parameter from the loop, because the actual parameter should stay here, so inside the nested resource. In this case, I can use this trick to have a parameter, can call it name, okay? And now this can be the file name. When I create a parameter in a data source, actually it will be reflected into the activity that is using the data source itself. Okay, so now I need to pass here the file name, and now here we have that as the parameter of the inner loop, the outer loop, sorry. So here I can say concat again, because now I want the item dot name and point parquet. Okay, let's go in the loop. Let's take out the breakpoints. Let's give a click of the debugger. And the good thing is that the for each by default is parallel. So we are using now 3, because the report types are 3 processes, okay, but under the hood are 3 pools, okay, parallel for data copy. So we can see them here in action. They are copying in parallel. They can finish one before, as you see, and the other one after a few seconds. And the result is that we have, okay, they are arriving. Okay. Some seconds more. Okay, the third one. I don't know why it's so long, but the good thing is we can scale up to many parallel workers, okay? Just an advice, okay? Those are the DEUs, okay? Stands for Data Integration Unit, okay? Data Integration Unit is the thing that you pay for, okay? So, my suggestion is to go into the details of pricing to fine-tune the usage of this DIUs, because you can spend a lot if you don't understand how to optimize them correctly. Okay. In this case, since I want to write to a single file, I give you as a suggestion that 2 DIUs are enough. Okay, but keep it just as a suggestion. Okay, just to resemble when you use that technology in the future. Okay, so we have those 3, and we consolidate our data with the data copy activity. We talk about the alternatives. So this data copy is very effective, no code, not low code, no code at all. And it's fast, but it's just an appender. Okay, so it can perform something like filtering, projection, like one column or another, changing the name, perform this data manipulation stuff. No, it's just an appender. Append files of different formats, well, of the same formats and same structure, okay, same schema. If I try to consolidate the 3 types in a single one, it will fail, okay? So I need to use data flows. Okay, that is fully featured. And if it's not enough, we can go to Spark pools. Okay, now let's consolidate all the 3 stuff together to produce what we can also call a gold layer, gold data set, with all the stuff aggregated to say, for instance, that no matter what the report type is, I just want for a single country all the cost. Okay, taken from all the reports, okay? This is the result we want to achieve. And we can go here and create a data flow in Parquet from this folder. This is a wizard, okay, but you can do it manually in a few minutes more. Okay, now I'm importing the schema. Another advice here, this is nice because it's read all the different files, and for instance I know that one has the country column and other type as the country code column, so the impression has country code and the clicks as country, no matter what. But if your data set has, if your folder in the data lake has millions of files, this is not going to investigate all the files, okay, but just the first several, but not all. So this can be just to start, but then you can overwrite your schema with your desired schema, okay? Now that I inferred the schema from that part, I want to take just two fields, country and cost, because I want that aggregation right now. So I keep out all this stuff, count, campaign, clicks, year, month, day, sellout, conversion, epoch. Okay, I have the country code in some report types that I want to transform into country, so to normalize different the types of reports. I take out creativity, impression, okay. Then I aggregate all the stuff by the column country, and what I am aggregating, the column cost with a simple expression that is sum of cost. Let's give a preview. And I can have a preview because before the session I started the debug session that it takes around 4 minutes to start because under the hood is spin up a Spark cluster, okay? And it can be paused in every moment, okay, but just to be fast in this demonstration, I just warm up before. This is another bug. Sometimes it works, sometimes not. This is the sometimes not. Okay, and but to be sure that it's working, I want to sync the results into where? Into the relational database, because now we are aggregating stuff, so it doesn't matter anymore of the complexity of the stuff that we are reading, because the result is just a few rows, one for each country. So let's define an inline dataset of type SQL. SQL database. Let's create a new connection to this one. Yeah. In the database demos, I think. Okay, this one. With the managed identity that I previously configured, of course, to work. Let's see it. Okay, it's working. And now that I connect the DB, I say, hey, use the advertising schema, and the table can be Igloo aggregates. I specify to recreate table each time because it's a result table. I don't want to append it, update data, and it's so small that I can recreate it every time. And this is okay. This data flow can be put into, oh, let's delete all this stuff, and I can just call this data flow into my pipeline. Data flow. Okay. Let's debug it. So, which is the lesson learned with the data flow is that we can handle schema drifting between input data set. We can project just the columns that we want. We can aggregate. We can do a lot of stuff, and we are just touching the spot of this technology, okay? And the result, of course, I hope, is a table that is called Igloo aggregates here with I hope all the countries. Yeah, all the countries. So the preview didn't work properly, but the actual result is okay. Good. But we change our mind several times in this world of data, because data grew up, because we had concerns in reading with the custom aggregations that can change over time, and it was so hard to maintain all the stuff related to the organizing properly the data lake. So we go downstream to the Spark pools and to the Spark tables and Delta tables. How many of you knows the concept of a Spark table or a Delta table? Okay, very good, a few, but it's really important. And now we are going deep into, no, not deep, but we are going to introduce those technology. So, okay, we are here. Let's take the aggregates, yeah, no problem. Okay. I have, this one that is ready, okay, better. Okay, which is the logic here? I'm reading from a source. In this case, the source is a Parquet file, but don't think about the input, because it doesn't make so much sense to read from a Parquet and write to a Spark table that is Parquet itself. Okay, but so just to be sure that you got the point, think about this as a load from external data set. Can be a SQL data set, can be a Parquet in this case, can be something else. Okay, the point that I want to put the finger on is this one. So I don't know if you see in the backstage. No, I can just increase here. Well, I think it's okay. It's okay. Okay, thank you, Peter. So in this case, I can write IglooConf plain table. Let's run this. And what is happening under the hood? That this Synapse instance, in conjunction with Spark, is writing a table inside an internal storage, and is writing it in the Parquet format. Okay, so again, we are talking about Parquet. Which is the lesson here? The lesson is, when you use a Spark table, first you need to use Spark, Python, .NET Spark, but it's better to use Python probably. But you don't see the resulting Parquet that you are generating. So there isn't so much tooling around Parquet in the world, and probably what my amazing team told me is that if there's no much support to read manually Parquet and convert them, probably because we don't do this manually so much, okay? Because we can handle them with a technology like Spark. What is performing this technology is creating in a special folder that is in the Synapse container, in the warehouse folder, a folder with the table name, with the Parquets that are the results of our process, aggregation, and so on. And interesting part, in the Synapse serverless pool, we have that table exposed as a, not really SQL, no, not yet, just wait a few seconds more. Okay, let's wait a few hours more. We have the concept of external table that we can query with SQL. Okay, so it's very similar to the pattern we used a few minutes before with the select star from URL. Okay, so let's see it in action. No, not this one. This one. Okay, succeeded, so I'm expecting to see the table here. Good. With this kind of table, unfortunately, we can just say, okay, insert into, no. Okay, so you are completely off the DML part of SQL. You can perform your DML with Spark SQL. So you can change here the language. You can say Spark SQL and say, okay, insert into EC plain table. Okay, values, well, the first one is date. Current timestamp. The second one is, I don't know, is country. Why? Account campaign. Let's make X. The cost 100, and the clicks, yeah. And then year, month, and day. Okay. This actually works. Under the hood, what's happening? That the Spark engine will create another parquet, okay, with this line. So if I make the select star from this table, where account equals to X. Of course, the select can be also made by the SQL engine, the SQL Server Management Studio. But we can't change the schema. We can't update a row. So if I try to update here, update this one, set cost 999, where account is X. It says me that, unfortunately, with external tables in the plain format, it's not possible, okay? Because, as I said, there are issues with the schema drifting when you deal with data lakes, okay? So if a parquet has 10 columns and I want to add a new one, it's a problem. If I want to change a row, since it's a column store format, think about the process. I should read the single specific parquet containing that row, read all the stuff in memory, update the row, and recompress all the stuff into columns. So it's something really almost impossible to achieve in a timely fashion, okay? But Databricks invented, or, well, supported really well, the concept of delta table. Delta table, we can create a delta table just saying to PySpark that the format is delta, okay? And again, let's change the name. Yeah, sure. Vabbè. Vabbè is the Italian of come on. Okay. Okay. And let's take another cell here at the end. Okay, let's run all the stuff. The delta format is a special format of organizing the data lake, always with Parquet, but also with a special folder called delta logs that contains all the differential incremental operation, all the schema-related features that are related to your data set. So if I create a delta table at time 0 and then I update the schema of the data or just a single row, a new parquet will be created with that row. And in this log, in this special log, will be put a information that you need to read that new row instead of the old row. And this is performed by the Spark engine. So this is succeeded. The update was succeeded, and the final select, in fact, has 99999. If we take a look to the, where is it? Okay. Here, in the warehouse, we have a new folder that is called Delta Table with few parquet. The first one is probably the first one. This one, that is the bigger one, yeah, is even the first one, is one created by the write, the initial write. I don't know why they are 3, okay, but the second and third is just the difference, the incremental represented by the update. So if I read inside it, I will find a row with the cost 100. And if I read this one, I found a row with the cost 999. But since there's the delta log here that describes all these kind of operations in a hierarchical way, the result is that we have now an external table, delta table, that is not getting the duplicates, okay, but just the good one with 999, okay. Instead, if I read, of course, by manually this data set with the serverless pool, even with the wildcard, of course, where account X, sorry, now just a second. Yeah, but after it wrote it inside this data source. So I'm not pointing in the sourcing part, but into the destination part of the Spark table. And I don't know why it's giving me an error. No, probably thinking about it. Okay, and now we have 2 lines. It's small, but you can see 2 lines. So if I read directly the Parquet, of course, I have a duplicate. But since I'm passing through the Delta format, there's this engine that deals with the complexity, of course, I have the latest one. Good. So this was our journey. And we are now here in this part experimenting. So I'm not telling you this is the way, okay, but this is our way to scale up, our way to deal with the complexity that is continuously growing up in the last few years. And pay attention to some points. I call it stability of source. Your source can change. Okay, so your report can change from a day to another date. You can just ignore the updates, so everything would go seamlessly, of course. But if you want to embrace the changes, of course, probably you will cope with the data drifting. Okay, so data drifting can be a pain. Also, the updatability is another thing that I want to push to you, is we are in a specific, if you're lucky, as I said at the beginning of the session, if you're lucky, you can just have append-only data sets. Okay, so it's great. You can just say, so let's start from the source where last update or timestamp greater than the last one. Okay, the last one you come from. But unfortunately, and in the destination, you can just insert. At least you can add new columns in some scenarios. But if you need to append, if you need to update your data set, and in our case, unfortunately, it is the 99% of the cases. So one day it arrives the updated data of yesterday, of 1 week ago. You need to pay very, very, very much attention to that kind of issues. And with a delta table, you can use both Parquet, that is scalable, and also update sources. With the intermediate step that I showed to you when I organize directly the reports into the data lake, it's not so easy to update the rows, okay? You just need to locate in the specific part of the data lake the right report and then overwrite it as a single file. And then if I have a consolidation process in place, I need to reconsolidate all the stuff to produce the result. Well, that's all I wanted to show you, and if time permits, yes, it is. We have like 6 minutes for the questions. You're welcome.
If you have a question, please ask.
Yeah, so how do you handle changing the code kind of gradually? Let's say your pipeline changes, how do you push it to production? What's your process for that?
Oh, well, actually, the good answer can be a version of my pipelines and so on, but unfortunately, we didn't do that yet because we experiment much hassle while developing inside ADF or Synapse. So actually, we are just have multiple lines with experimentation, and we just push into the proper ones when we have the right result. But not because it's not possible or is not suitable, because we are not ready yet to have this kind of mature process around this data ops operations. Okay. Sorry to be so general.
Sorry, how are the data scientists accessing the data?
Sorry?
How the actual data scientists access the data?
Well, this is a challenge that we are probably solving in the sense that in our data platform scenario, we don't want that the data scientists access directly to the data lake, but to what we call the consumer endpoints. Okay, so think about the data platform split in two. The source-aligned data sets, so the data sets really similar to the form that they comes in the data platform, and the consumer-aligned data set. So after some joining, after some aggregation, after some enrichment from other data sets, so in a continuous loop, you can take three sources, join together, then take another source, enrich the data, make an aggregation, and this is what business wants to start with. Okay, so this is the consumer-aligned data set. So we want to expose just that result in where? Since it's not our master data, our single point, single source of truth, because the single source of truth is the sourcing part, those are just copies. So the consumer-aligned data set are pipelines, okay, that produce copies of the data. And those copies have been accessed by the data scientist, in our case, through the data source feature of AML Studio, for instance, that abstracts the access to the blob with like a container, like a abstraction. Okay. Welcome.
A little bit related to the first one. Do you know if it's possible to set up the stuff inside Synapse with ARM templates or build, let's say, data flows?
No, it's not possible. We try to for a backup purposes, but it's not possible. The short answer, for the audience, excuse me, we are recorded and I didn't reply the question for our audience. In this case, the question is possible to recreate all the stuff in the inside Synapse with ARM? My short reply is no, it's not possible. It's a mix between ARM just for the provisioning of the Synapse workspace itself and then Git for the resources inside Synapse.
Is there a big price difference between these three
Between what?
Is data copy and data flow?
Yeah, sure. Okay. Yeah, the question is there a big price difference between data copy and data flow? Yes. Well, in terms of the model, the entire model, okay? In the data copy activities, you pay 1 hour of DIU about €0.25 or dollar, I don't remember, okay? But as I said before, you should investigate into the actual usage of that DIUs. For instance, if you have a parallel copy of 100 partition to other 100 partition, you can have like 100 DUs, probably something less, like 64. For the time, it's enough, okay? And this can raise up to hundreds and $1,000 spending to perform the operation in few seconds or few minutes. So you can probably decide not to go in parallel, but to go in sequentially to save some money if you have not the time constraint to perform your activity in a few minutes. And this is the first point with data copy. Data flow instead is built by the vCore hour of the underlying Spark pool that runs your workload. And that's a completely different point. It's not a $0.25. It depends. I don't remember at all. And depends of how many cores has your underlying pool that, just to remember, is started on demand. So it's not something that stays uptime all the time. Okay, so I don't know if I replied to you, but the pricing is very different. I can say one is more than the other one. For instance, at the beginning, for us, data flow was too expensive, but just because we didn't use it so well. Okay, now probably with a data flow that is Spark-based, we can optimize the cost instead the data copy activities. And with Spark pools, again, we can spend even less because we are really fine-tuning the operation and stay really compressed in time.
Excellent. Thank you, Roberto.
To you.